everyone. Today we will discuss real-valued functions. A function is said to be real-valued if its range is a subset of the set of real numbers. Unless otherwise stated, all functions throughout this discussion are assumed to be real-valued functions with domains that are subsets of the set of real numbers. A real-valued function f is defined at x if the image of x under f is a real number. If the domain of a real-valued function f is unspecified, it will be taken as the set of all x at which f is defined. Now, we are going to consider some examples on how to find the domain and image of some functions. First, let's consider the function f of x equals x squared. The domain of this function is clearly the set of real numbers because this function is defined for any real number x. As you can see, when we substitute the values of x taken from this domain, f of x is always non-negative. Hence, we conclude that the image of f is the interval from 0 to positive infinity. Let us now take a look at the function g of x equals the square root of x minus 2. For this function to be real-valued, the radicand x minus 2 should be non-negative. This is equivalent to saying that x should be greater than or equal to 2. Thus, the domain of g must be the interval from 2 to positive infinity. As you may already guess, the image of this function is the interval from 0 to positive infinity as seen when you substitute the values of x coming from this domain. How about if the given function is h of x equals 2 all over x plus 5? From here, we can easily see that the domain of this function is the set of real numbers except for negative 5. This is the case because when x equals negative 5, the denominator becomes 0, making this expression undefined. To find the image of this function, we are going to use the functional notation. That is, we let y be equal to h of x so that the given function becomes y equals 2 over x plus 5. What we are going to do next is to solve for x in terms of y. Notice that multiplying both sides of this equation by the denominator x plus 5 gives us the quantity x plus 5 times y equals 2. Dividing both sides of this equation by y gives us x plus 5 equals 2 over y. Now, when we solve for x, we will have x equals 2 minus 5y all over y. Examining this expression, we can see that the image of this function is the set of real numbers except for the value y equals 0. Let us now discuss functions derived from equations. Any equation of variables x and y may be written in the form f of xy equals 0, where f of xy denotes an expression in terms of x and y. If this equation defines a relation R which is a subset of the Cartesian product of two sets of real numbers, any subset of R which is a function is called derived function. Let us consider some examples on how to find some functions derived from equations. First, we have the equation 3x plus 2y equals 1. What we are going to do is to solve for y in terms of x. Notice that this equation can be written as 2y equals 1 minus 3x. Dividing both sides of this equation by 2 would give us y equals 1 minus 3x all over 2. If we let y be equal to f of x, then this equation becomes f of x equals 1 minus 3x all over 2. This is our function which is derived from this equation. Clearly, we can see that the domain of this function is the set of real numbers. To find the image, we are going to solve for x in terms of y in the given equation. To do so, notice that we can write the equation as 3x equals 1 minus 2y. When we divide both sides of this equation by 3, we will have x equals 1 minus 2y all over 3. From here, we can see that the image of f is also the set of real numbers. How about the equation x plus xy plus y equals 1? Like what we did in the first example, we first solve for y in terms of x. Notice that we can have xy plus y equals 1 minus x. In the left-hand side, we can factor out y so that we get y times the quantity x plus 1 equals 1 minus x. If we divide both sides of this equation by x plus 1, we will have y equals 1 minus x all over x plus 1. If we let y be equal to f of x, we will get the derived function f of x equals 1 minus x all over x plus 1. Here, we can clearly see that the domain is the set of real numbers except for negative 1. To solve for the image, we will now solve for x in terms of y from the original equation. Notice that we can have x plus xy equals 1 minus y. Factoring x in the left-hand side would give us x times the quantity 1 plus y, which is equal to 1 minus y. If we divide both sides by 1 minus y, we will have x equals 1 minus y all over 1 plus y. From here, we can see that the image of the function is also the set of real numbers except for negative 1.